Hello guys, good day. I am Mark Genesis S. Bayumbon, aspiring chemical engineer from Technological Institute of the Philippines, Manila. Today, we are going to discuss one of the most important and useful unit operations in the field of chemical engineering, which is distillation. First, let's define what is distillation. Distillation is one of the most common liquid-liquid separation processes in which separation is based on differences in the conditions required to change the phase of components of the mixture. To separate a mixture of liquids, the liquid can be heated to first components, which have different boiling points, into vapor phase. The vapor is then condensed back into liquid form and collected. Now, to be specific, our main topic for today's discussion is all about distillation column. Distillation column is an essential equipment or item used in the distillation of liquid mixture for the separation of its mixture fractionally and into components with respect to their volatilities. Here, separation is classified into two. First is the complete separation, wherein both components are nearly pure and both concentrations of the components were increased. Next is the partial separation, wherein only the selected components will increase its concentration. Now, we go on to the main components of a distillation column. Distillation columns are made up of several components, each of which is used either to transfer heat energy or enhance material transfer. To easily visualize the parts of a distillation column, here is an image of a distillation unit. The first part of a distillation column is a vertical shell. Here is the vertical shell. A vertical shell where the separation of liquids component is carried out, and it houses the column internals together with the condenser and reboiler, which constitute a distillation column. Next is the column internals. Here is the column internals. Column internals such as trays, plates, or packings, which are used to enhance component separation. Next is the reboiler. The purpose of reboiler is to provide the necessary vaporization for the distillation process. Next is the condenser. Condenser to cool and condense the vapor leaving the top of the column. Last is the reflux drum. The purpose of reflux drum is to hold the condensed vapor from the top of the column so that the liquid or reflux can be recycled back to the column. Now, I will explain the working principle of a distillation column. The liquid mixture that is to be processed is known as the feed. And this is usually somewhere introduced near the middle of the column, here, or a tray known as the feed tray. The feed tray is divided into a top, which is called enriching or rectification section, and a bottom, which is called stripping section. The feed flows down the column where it is collected at the bottom in the reboiler. Heat is supplied in the reboiler to generate a vapor. The vapor raised in the reboiler is reintroduced into the unit at the bottom of the column. Here, the vapor here. The liquid removed from the reboiler is known as the bottom product or bottoms. The liquid here is known as the bottoms. The vapor moves up the column. The vapor will move up. As it exits the top of the unit, it is cooled by a condenser. The vapor here will be cooled by the condenser. The condensed liquid is stored in a holding vessel known as a reflux drum. Some condensed liquid that is removed from the system is known as the product or distillate. Here is the final product, the distillate. Now, we go on to the types of column internals. First is the plate or tray column. The plate or tray column is the most widely used type of distillation column. The number of trays or stages in the column is dependent on the desired purity and difficulty of the separation. The number of stages also determines the height of the column. Plate or tray columns are often used to recover solvents for process wastes. As you can see in the image, this is the feed, and this is the trays or plate. The feed enters a plate or tray columns toward the middle of the column. Concentration differences cause the less volatile components to transfer from the vapor stream to the liquid stream. The vapor exceeding the condenser contains the most volatile components, while the least volatile components exist through the reboiler in the liquid stream. Next is the type of the plate or tray column. First is the bubble cap tray. A bubble cap tray has a riser or chimney fitted over each hole. Here is the cap. Here is a riser. The cap is mounted. Here, as you can see, the cap is mounted so that there is a space between the riser and cap to allow the passage of vapor. Vapor rises through the chimney and is directly downward by the cap, finally discharging through slots in the cap, and finally bubbling through the liquid on the tray. Next is the sieve tray. Sieve trays are simply metal plates with holes in them. Vapor passes straight upward through the liquid on the plate. The arrangement, number, and size of the holes are design parameters. You can see in the image that if the vapor is under normal operation and if the vapor is under low flow condition. Next is bulb trays. In bulb trays, perforations are covered by liftable caps. Here is the liftable caps. Vapor flows lifts the caps. The vapor here will lift the caps, thus separating a flow area for the passage of vapor. The lifting cap directs the vapor to flow horizontally into the liquid, thus providing better mixing is possible in sieve trays. Here you can see how normal, low, and high vapor will lift the caps. Now is the liquid and vapor flows in a tray column. Each tray has two conduits. One conduit here and one conduit here. One on each side is called the downcomer. Here is the downcomer. Liquid pulls through the downcomer by gravity from one tray to the one below it. And a wear. And here is the wear. A wear on the tray ensures that there is always some liquid or hold up on the tray, and it is designed such that the hold up is at a suitable height, for example, such that the bubble caps are covered by liquid. Being lighter, vapor flows up the column and it is forced to pass the liquid by the openings on each tray. The area allowed for the passage of vapor on each tray is called the active tray area. Here is the active tray area. Finally, we go on to the advantages and disadvantages of plate or tray columns. The advantages of plate or tray columns are: first is the most cost-efficient distillation column for diameters greater than 0.6 meters. The liquid or vapor contact in the cross flow of plate columns is more effective than the counter-current flow in pack columns. Cooling coils can easily be added to the plate column or cryogenic application. Can handle high liquid flow rates cost effectively. The disadvantages of a plate or tray column are: first is higher pressure drops than pack columns, which could cause some column flooding. And foaming can occur due to agitation of the liquid by the vapor flowing up through it.
Okay, let's now proceed to packed bed column. Packed bed columns are used most often for absorption. They're also used for distillation of vapor liquid mixtures. The packing provides a large surface area for vapor liquid contact, which increases the column's effectiveness. Packed bed columns are often used to recover solvent. So um, packed beds are typically columns filled with a packing material that allows fluids to flow from one end to another. So electrical tomography may be used to observe the distribution of liquids at different cross sections of the vessel, or indeed the flow pattern throughout the pack column. The pack column are used in the petrochemical industry. So let's now proceed. The feed mixture contains components of different volatilities and enters the columns approximately at the middle. The liquid flows downward through the packing and the vapor flows upward through the column. So differences in concentration cause the less volatile components to transfer from vapor phase to the liquid phase. The fact that the packing increases the time of contact, which increases the separation efficiency. The exiting vapor contains the most volatile components, while the liquid product stream contains the least volatile components. So in standard pack observation columns, a gas mixture travels up through a gas absorption tower, and so and the solute is transferred to the liquid phase and thus gradually removed from the gas. The liquid accumulates solute on its way down through the column. So this is the image of a packed distillation column with its parts. So this is the flange, the reflux line, the liquid distributor, the hold down screen, the interdistributor, the packing support, the vapor inlet, and this is the pipe to still. This is the pipe to vapor inlet. So this is a short animation for a packed bed columns. So as you can see, after the feed mixture contains or enters rather to the column, as the green arrows, this is the green arrows, um, in the animation below demonstrate liquid flows down the column through the packing counter currently and contacts the rising vapor stream. The liquid at the bottom, which is highlighted in yellow, this is the liquid. This is the liquid, the yellow part. Um, Enters a reboiler. So two streams exit the reboiler: the vapor stream, which returns to the column, and the liquid product stream. The vapor stream flows upward. So this is the vapor stream, the blue line, the blue arrow rather. Um, Flows upward to the packing, picks up more volatile components, exit the column, and enters a condenser. This is a condenser. The yellow, the gray circle in the upper part of the column. So that's the condenser. After the vapor condenses, the stream enters a reflux drum where it is split into a overhead product stream known as the distillate. So this is the distillate. And a reflux stream that is recycled back to the column. The feed passes through the packing to maximize vapor liquid surface contact for an efficient separation. So this is what happened inside the distillation column. So let's now proceed. Types of packed bed column. So these are the types of packed bed columns. These are the metal packings, ceramic packings, plastic packing, and stock packing. Metal packings have a high strength and good wettability. So when we say wettability, um, it pertains that the ability of a liquid to maintain the contact with a solid surface and is controlled by a balance between the intermolecular interactions of adhesive type and cohesive type, which is important in distillation ceramic. And okay, so the second one is the ceramic. Okay, so that's the definition of wettability. So the next one is the ceramic packings, and it has a higher wettability than metal packings, but they are not so strong. So next one is plastic packings. It have rather sufficient strength but experience poor wettability at low liquid flow rates. Because they are corrosion resistant, ceramic packings are only used at elevated temperatures where plastic packing would fail. So the next one is the stack packing. Stack packing is a structured meshwork of the same diameter as the column. It provides the long interrupted channels for liquid and vapor flow, although they are more expensive than dump packing. Stack packings result in a lower pressure drop. Stack packing is preferred for low liquid flow rates and in low pressure situations. They're typically made of wood, sheet metal, or woven case. So, among these packed bed columns, the packings mentioned in this presentation, the the superior wettability among them is the ceramic packings. So it has a higher wettability, but it not so strong. So the advantages of a packed bed column. So most cost efficient distillation column, the diameter of the column is less than 0.6 meters. Why it matters? Because this is because packing can be made from non-reactive materials. Therefore, the packed beds are able to withstand corrosive materials. So that's one of the advantages of a packed bed column. So next one is because packing can be made from inert materials. Packed beds are able to handle corrosive materials. So the third one is lower pressure drop than in plates columns, preventing column flooding. So the lower pressure drop in plate columns causes um, less tower flooding. So the next one is good for thermally sensitive liquids. The last one for its advantages is suitable for low pressure operations. So one of it's this so these are the disadvantages of a packed bed column. So packing can break during installation or due to thermal expansion. Um, Not cost efficient for high liquid flow rates. And the third one is contact efficiencies are decreased when the liquid flow rate is too low. So the applications of distillation column. So distillation column can be used to manufacture alcoholic beverages, the production of gasoline, perfume, xylene, paraffin, kerosene, and the most important of all, and the most commonly used in distillation column is oil refining. So distillation is used to separate liquids from non-volatile liquids, as in the separation of alcoholic liquors from fermented materials, or in the separation of two or more liquids having different boiling points. So this was used in the separation of liquid mixture in also in gasoline, kerosene, and lubricating oil from crude oil. So in oil refining, crude oil is made up of a mixture of hydrocarbons, as we all know that, and the distillation process aims to separate this crude oil into broad categories of its component hydrocarbons or fractions. Crude oil is first heated. So this what happens in distillation column in oil refining. So crude oil is first heated and then put into a distillation column, also known as a still, where different products boil off and are recovered at different temperatures. So those are the applications of distillation column. So next one is, what are the two types of distillation? So there are mainly two types of distillation which involves the use of columns. Each were designed to perform a specific types of separation, and each design differs in terms of complexity. So the first one is batch distillation and continuous distillation. So in batch distillation, um, batch distillation is a process in which two liquids with different boiling points are heated, excuse me, vaporized, and then cooled to obtain a new product with a concentration higher in one of the two liquids. During a batch distillation, no new liquids are added to the heating vessel, so over time, the product concentration will change as the mixture is boiled and the final product is removed. In batch, the feed to the column is introduced batch-wise. So take note of this. In batch distillation, the feed to the column is introduced batch-wise. So it means it is per batch. So that's why it is called batch distillation. So the distillation is carried out after attaining the desired composition. Next batch will be introduced. So this is the diagram for the batch distillation. So what happens here? So feed is charged to a steel pot to which heat is supplied continuously through a steam jacket. So as mixture boils, it generates vapor richer in the more volatile component. Condensate will be richer in the more volatile content at the beginning, but decreases as more condensate keeps accumulating. So the feed enters here in the column, and after some operations with its vapor and the liquid, it will go way up to a condenser and to the reflex drum and to a receivers. So that's what happens in batch. The next type of distillation is a continuous distillation. Continuous distillation is an ongoing separation in which a mixture is continuously fed into the process and separated fractions are removed continuously as output streams. No interruptions occur unless there is a problem with the column or surrounding process units that are capable of handling high throughputs. So when we see continuous distillation, the feed is continuously fed into a column from a tank. So there is no interruption, there is no sudden stop from the separations unless there is a problem on the column itself or the surrounding process units. So the columns used for this method may have many different exit points from different products since they are all being removed simultaneously. Each exit point is placed at a different height on the column according to where the vapor condenses as it falls. So this is the diagram for the continuous distillation column. So the feed is fed into a column using a pump. It is from the tank. So in this operation, feed is stored in a tank, then used to move the feeder from a preheater. In the preheater, the mixture is heated under pressure to just below its boiling point. When the feed enters the lower part of the column, it is already boiling. So the boiled vapors from the boiling liquid, which primarily contain the lighter components in the feed, rise in the tower liquid, is thrown off as the bottom's product and the router to a reboiler. So a liquid will be the bottom's liquid will go to a boiler. So there some vapor that will condense and it will go way back into a column. So the vapor rises and this column will go to a condenser in the upper part of this distillation. Then a cooling water will be used to cool the vapor. Then it will go to a reflux drum. So distillate will serve as our overhead product. So those are the processes involved in the continuous column. So thanks for watching and listening. I hope you guys learned something today. Thank you.